Okay, a probability distribution, a table, lists all the outcomes, which are x. P of x stands the probability of each one. So determine if something's a probability distribution. Each of the probabilities, the P of x, has to be between 0 and 1. It can't be negative and it can't be more than 1. So each thing in P of x column satisfies that. The other condition is that the sum, okay, that funny looking E means to add. If you add up all the probabilities, they equal 1. So since both of those conditions are satisfied, it is a probability distribution. Okay, now if it asks to find the mean, the first thing you do is make a table column, a second column where you multiply each x times its probability. So that third column, you're going to multiply x times P of x. To find the mean, you add up that column of where you multiplied, okay? Add up that third column. To find the variance, there's another table that you're going to make. You're going to make a column of x squared, which means you multiply x times itself. So 0 times 0 equals 0, 1 times 1 is 1, 2 times 2 is 4, and so forth. Okay. Then you make another column where you multiply x squared times the P of x. So if that first one, you multiply 0 times 0.024, 1 times 0.167, okay, 4 times 0.309. So you do all those multiplications. Then you're going to add everything up in that last column. Okay, so add everything up in that last column, you get 7.456. Okay, and then the standard deviation is this formula. Okay, so we're going to take the square root of something. That first thing, the sum of x squared times P of x, that's the 7.456 we just found. Then you subtract the mean squared. That curly looking M is the Greek letter mu, and we use it for the mean. The mean we found in the first part was 2.5. So 2.5 squared is 2.5 times 2.5, which is 6.25. So I plug those two numbers in, subtract, and take the square root. Okay, if it says round to 1 decimal, the first decimal is 0. To the right of 0 is a 9, which tells that 0 to round up to a 1. If any probability is negative or more than 1, it's not a probability distribution. If you add the probabilities and the sum does not equal 1, it's not a probability distribution. Okay, an example of probability with insurance, life insurance. If the person survives, they lose the premium paid. Okay, they paid the premium and they lived, which is a good thing, but they paid out that premium, so they spent that money. If the person does not survive, the beneficiary gets the policy amount. Okay, so let's say the premium was $198 and the policy is $100,000. So if the person survives, the result for the person is they lost $198. They spent it. If the person dies, the beneficiary gets $100,000, but they spent $198. So the result is a gain of $99,802 in terms of money. The expected value, you multiply x, which is a result, times its probability. Okay, if the problem says the probability of survival is 0.9981, The probability the person does not survive is the opposite, which is 1 minus that, 0.0019. Okay, so then we make a table. The result of the person surviving is losing the $198. The probability of survival is 0.9981. The probability of not surviving is 0.0019. And the result of that is a gain for the beneficiary of 99802. So you multiply each result times its probability and add those two together. Okay. Now, -8, we're looking at this in terms of the eyes of the policyholder. So it's a loss for the policyholder on average, which is a profit for insurance. Okay, this is how policy payouts and premiums are determined, because the insurance company is not going to stay in business unless they make money, more money on average than they spend out. Okay, another example. Suppose 48% use smartphones in a certain situation. If 6 users are selected, what's the chance that exactly 3 of them use their smartphone in this situation? Okay, so you're going to go to that website, stattrack.com. Okay, I ran out of space, so that last /binomial goes at the end of calculator. Okay, what you're going to plug in, the probability of success is 0.48. That's 48% changed to a decimal. The number of trials is the 6 people chosen. The number of successes is 3. Okay, so you're going to go to that website calculator, and you're going to put those values in and hit calculate. Now, it gives a lot of answers. It's going to give answers for exactly 3, less than 3, more than 3. We're going to use exactly 3 from the problem. So we're going to look at all the different answers, and we're going to look where it says x equals 3, and that's our answer. Okay, what if it's a similar example? Let's say it says 54%, 6 are selected. Find the probability of at least 4. So we're going to use that same website, StatTrack. It's an online calculator. For the probability, it said 54%, so put in 0.54. 6 people are selected, so that's our number of trials. We're finding at least 4, so we're going to put 4 in for the number of successes. But this time, after we hit calculate, at least 4 means 4 and bigger. So we're going to look at all the different answers, and the answer you want to choose is the one that says x is greater than or equal to 4, because that corresponds to where it says at least 4. Okay, the probability that peas have green pods is 0.75. Randomly selected groups of 52. The mean, okay, you multiply n times p, which is the same thing as finding 75% of 52. So that gives us the mean of 39. The standard deviation, okay, that curly looking r is the lowercase sigma Greek letter, and it stands for the standard deviation. We multiply n times p times q. Okay, n is the 52 number selected. P is 0.75 because it said probability. Q is the opposite of P, so you do 1 minus 0.75, so Q equals 0.25. So multiply and then take the square root, and that gives you a standard deviation of 3.1. Okay, now it asked for what are the significantly low and high values. Significantly low uses the formula mean minus 2 times standard deviation. So plug in 39 that we found for the mean and 3.1 for the standard deviation. Okay, for the significantly high, you add instead. Okay, now be very careful. Let's look at the equation for low, 39 minus 2 times 3.1. The order of operation says you multiply before you subtract. So you have to do 2 times 3.1 and then do 39 minus that. Okay, for significantly high, you have to do 2 times 3.1 and do 39 plus that because we multiply before we add and subtract. Okay, so those values are between 32.8 and 45.2 are not significant. Okay, if they're between, they're not significant. Okay, significantly low would be less than 32.8. Significantly high would be higher than 45.2. So is 22 low? Yes, because it's lower than the lowest number, 32.8. Okay, anything in between is normal. Anything outside of that is abnormal, either significantly large or significantly small. So 22 is significantly low because it's less than that lower bound of 32.8. Okay, that's the end of our lesson.